In this video, we'll talk about how traffic shaping is configured in AirOS. Ubiquiti introduces a simple, easy way to create powerful traffic shaping policies. Traffic shaping is a good way to ensure that networks perform expectedly, even despite high traffic volumes. Within the Network tab of AirOS, traffic shaping can be enabled when Advanced Configuration Mode is selected. There are 4 terms to understand when dealing with AirOS traffic shaping. Ingress refers to inbound traffic on a given port. Think incoming when you hear ingress. Egress refers to outbound traffic on a given port. Think exiting when you hear egress. We recommend using traffic shaping to control egress traffic because it is more efficient in the egress direction. When a port accepts ingress traffic, it cannot control how quickly the traffic arrives. The sending device controls that traffic. However, when a port sends out egress traffic, it can control how quickly the traffic exits. Rates refers to the maximum bandwidth value in kilobits per second for traffic that is passing through a given port. Burst refers to the data volume in kilobytes that is allowed before the egress maximum bandwidth applies. Burst is similar to a bucket, which, once filled, starts rate limiting. As the bucket empties, or as time passes, traffic again may pass without limits until the bucket fills once again. The diagram shows a station radio configured as a simple bridge. Imagine that the station radio is a CPE with a host computer connected on the LAN interface and an AirMax AP connected to the WLAN interface. Traffic shaping is not only useful, but recommended for keeping customers within fair bandwidth limits. This way, customers with viruses or programs which consume large amounts of network bandwidth won't cripple the rest of the network. For a client with a 10 megabit down, 5 megabit up package, the egress LAN rule reflects download speed, while ingress is left disabled. The egress WLAN rule reflects the upload speed, while ingress is once again left disabled. By leaving burst set to 0, customers will pass traffic at the specified rates as long as they have traffic to send or receive. Specifying a burst parameter is a great way to hyper-exaggerate the performance of a link. If the download burst size is 5 megabytes, this means that the customer can download up to 5 megabytes as fast as the link permits before the rate drops to 10 megabits per second. The interval of time before limits are lifted is directly dependent on the ratio of burst to rate limit. Convert the burst size first into bits, then divide the burst size by the rate limit. So after approximately 4 seconds without passing traffic, the burst bucket is again empty and the client can pass traffic without rate limits. Lowering a radio's modulation rate is not a recommended way to create traffic shaping rules, since it can hinder the performance of the entire radio network.